Hello and welcome to Talking Shit About. This is Elizabeth, and each month I bring on someone to talk about something they love, something they hate, and hopefully by the end we've all learned something. I have a wonderful interview lined up for you today, and I hope you enjoy this conversation on artificial intelligence. Let's talk some shit.
I was like, what the fuck does that mean? I have friends that are firefighters and I know that they use soap.
And she was screaming at me over soup.
Fuck this, I am not ever talking to a Scientologist again. These people are all insane.
I'm putting my bricks in the dumpsters, motherfuckers. Do you see me, bitches? I'm throwing my bricks. And he's just like chucking bricks.
Hello, everyone, and welcome to Talking Shit About today. I'm here with Allison, and we're going to be talking about AI, which is artificial intelligence. Allison, welcome to the show. How are you doing?
Yeah, I'm doing great. Thanks for having me on.
Yeah, I'm excited to have you here. This is a topic I've wanted to cover for a while. It's not something I know a lot about other than like what I've seen in sci-fi movies and video games and stuff. So I'm excited to learn how it really works kind of in the real world right now.
Yeah,
Um,
it's a weird time for this because like right now we're getting eerily close to that kind of sci-fi feel. I don't know how much like you've looked into accounts of people that are like building stuff in AI, but like on Twitter, I see all the time people being like, "Oh, I saw this thing in a movie. I'm gonna build it," and now they're building it.
it's amazing how sci-fi works to like inspire technology change. So, can you give us, assuming somebody knows, artificial intelligence, it's a computer, it's making decisions, but can you give us a little bit more in depth of what AI
Mhm.
is and sort of how it functions?
Yeah, so I think there's a few ways to look at it, right? Because the way people define AI kind of changes a little bit over time. I think most simply, the definition like a computer making a decision, which if you have anybody who has any background programming, that technically is an if statement, right? So you can have like I don't know, you measure two things, and if they're the same, output this, otherwise output this. That is technically a form of AI, but that is such a like simplistic thing that most people wouldn't think about that level of complexity as AI because that would basically have majority of computer code being AI. So what you can typically imagine in kind of the modern current context being referred to as AI has to typically do with machine learning. What that is, okay, you can imagine it as if you drew a bunch of circles on a paper and you connected them together and it all they all went from left to right. There's like a direction on all the arrows, and each of those little circles would do some kind of mathematical operation on whatever it was sent to it, and then at the end it all kind of goes to some series of inputs. So you have a bunch of lines coming in, they give you a bunch of numbers, these random circles do weird operations, doesn't matter what they do, I'll explain that bit later, and then that puts it out. So that is essentially what like a neural network is on a computer. It's a bunch of circles connected which do different mathematical operations. And then the point of machine learning or like doing this kind of training is, well, depending on the approach, because there's some where you have data from before, there's some where you don't, there's a lot of different versions, but it's basically trying to have the operations that each of those circles does be different and changing them constantly as you kind of try to find out what works best. That is the simplest explanation I can think of that is like very technically accurate to how it works. A more general way is basically you give a computer a bunch of data, you either tell it what you want it to do or you don't tell it what you want it to do, and then it keeps trying shit until it either works or you give up.
Awesome. I appreciate the visual. So how did you get into AI and this field? What drew you to it?
So from I think it's hard to find like a good starting point because I could like now I'm thinking about it, and sometimes when people ask about it, I thought about I answered by like, oh, when I was younger, when I got into coding and playing with this, that kind of led me into it. But then there's also like later starting points where I specifically did stuff around machine learning and stuff like that. So I think more generally, everybody has an interest in like making computers think, quote unquote. And so there is, an aspect like once you learn some of the enough technical stuff to be able to do some of that like more AI centric stuff, you want to try it. So I've had, sometimes where I've like messed around with it for like random automation stuff. Like one of the things I did for a period of time when I was much younger, was so I had like pressure sensors that I put into the mattress of my bed, and I was trying to optimize it where it would basically start a coffee machine based on when it expected me to wake up. And I just try to train an algorithm on it just so that I could like have everything up and running by the time I would be like up and going downstairs, because that machine took like 15-20 minutes to fully start up. So way too long to be like switch it down and then go do other stuff. So I think that was like my proper first messing around with it when I was much younger. And then for what we were working on up until recently, I think what drew me there was partly more the physics side of it, right? Because I studied physics. I studied physics. That's my background, like by education. And what we were looking at with the computer vision stuff was very much more of a, well, in the understanding of it was more of a physics problem where like, well, different frequencies pass through different materials differently. Which I know I said different many times over just now, but essentially like, some things are transparent to visible light that we see. Some things are transparent to infrared. Some things are transparent to whatever else. And, that's a good way to think about that penetration. And there's also the way they kind of change their shape, quote unquote. So all of those were kind of some of that idea behind what we worked on until recently. So I think that's what drove me to try pursuing that computer vision thing that I was looking into more recently. But yeah, for some reason I keep coming back to it because so many, it's a very useful tool in all kinds of projects, like all kinds of problems that you try to look at and solve.
Yeah, so tell me a little bit about this tool that you've been working on.
All right, so I think I'll briefly explain what computer vision is in case someone's not familiar with it. So computer vision is, in a kind of what's currently most common, is you have some kind of photo or some kind of video feed and you identify if something that you're looking for is on there or not on there. The way these are trained are through that machine learning system that I outlined earlier. Some very specific versions of it, but essentially one of those is used. And then, if you go further back in time, what was most common, you would have it trained to, for example, recognize if a screw is present on that image. So I don't know, you would have you have a camera that's looking at a assembly line and it's checking if screws are all there and screwed in. You might see it in like movies when there's like CCTV cameras and it's like, ooh, look at this person, and it kind of puts a frame around the person, stuff like that. That is slightly more modern computer vision. Nowadays, we're we're even closer, where we're using slightly more generalized models. So when you're, for example, looking at what like a self-driving car, like the Tesla, if you ever seen that picture that it like outputs on the screen in the middle where it's like showing, oh, there's a car, there's a person, there's a traffic cone, here are the lines. That's all done using cameras because I'm not sure if a lot of people know this, but Teslas don't actually nowadays have a LiDAR detector. So they used to use LiDAR, and that's what majority of like people that are trying to build self-driving cars do. But more newer Teslas only have a camera. So it was just computer vision used to kind of detect stuff. So that's the current technology. And what we started to look at was like, well, yes, there is a lot of information in the visible spectrum, but why not everything else, right? Because you have, like, there was a research paper that we saw that was using Wi-Fi to see people through walls. So you would have, you'd have Wi-Fi that's being output. You build an array that's going to pick up the Wi-Fi signal. And then just because there's Wi-Fi signal and you know where it's coming from, you can see people through walls. And it was testing, like, could you measure, gestures with it? Could you see through it? Stuff like that. And a few papers in, so once they were refining this in their research, they could detect such fine movements that they could detect a person breathing. They could just see people through walls, see how they're breathing, and all of this. So we were looking at it being like, well, that's great. So this is clearly viable in other parts of the spectrum. Why not use all of it? Use everything from UV through IR through all the radio, everything in the spectrum, because there is so much useful information there that we're like, well, if we train a model on it, that information can be used for all kinds of stuff.
So what are the, I guess, some like more specific potential benefits of or uses for it?
Sure. So I think one of the kind of most obvious ones that as we were talking about it, we were like, well, obviously this is an intelligence, right? If you're, I don't know, like if you want to, like the example of people, you want to see people through a wall, right? You're a police that wants to like observe a building. There you go. Like you can see people through a wall. You could see what kind of material stuff is from. So I think in construction, so like let's say you have a building and you had an array that would like pick up a whole range of signals, well, like the whole range of the EM spectrum. You could identify what materials different parts are made of. So you can be like, oh, that part is a 6-inch concrete wall. That's a 12-inch wall with rebar. That's a steel beam, and etc. Just like on the building. One of the very interesting ones we were looking at is that so within cities, you have a lot of known Wi-Fi sources. So there's like public Wi-Fi, all of these. So you know where they are, and you know what kind of the pattern that they're broadcasting. Because Wi-Fi sends out a ping, which is how your phone picks it up. So how you can see, oh, there's Wi-Fi network there. So these are regular bits of signal being sent out with a known location. So we were looking at it where we were like, well, if we account for these 2 bits of information, we could integrate that into a system where your self-driving car would be able to see behind corners, but stuff that visibly isn't there. Because one of the limitations of having a self-driving car is you have to get all of the information from the inside, right? You see these concepts where people talk about like, oh, if it was an interconnected city and everything communicated, it would be so much more efficient. Yes, like if you fully automate how the traffic and all of that flow is driven by a computer, you could do crazy complicated stuff that would just seamlessly work. But the reason we don't do that is because that's not really feasible to suddenly switch an entire city into being automated. But one of the big benefits of those concepts is that you have external information to work with, right? So you have cameras that are outside the vehicle that can maybe, process some information, let the vehicle know like, hey, stop, there's a pedestrian walking behind the corner that's about to run out, but the car can't see them. So with the use of these, Wi-Fi networks that are sending these regular signals from a known location, we could pick them up, and based on the pattern of how they're diffracted, what their signal strength is, et cetera, you could compute literally what's behind a corner. So in a way, you could literally see behind corners.
That's cool. Do you ever worry that that kind of technology could be like weaponized? Like you mentioned police, like do you see like the military utilizing that kind of technology?
I think like if anybody is going to use this, it's going to be the military, and they're going to use it first. So like I don't think for me, I don't quite think of it as a worry for something like this, because I look at it as like, this isn't in a way obvious development that somebody has to build. So the chances are that the military has already built this and it's classified and we just don't know it because they don't make this kind of stuff public. So like me building is not going to change anything. And also I'm quite like public and open about what I'm building. So, if somebody tries to classify my work, people already know what we've built.
Yeah, we've got it on the record here. Yeah, I heard, I didn't read into it or anything, but I heard that the military is using AI somehow involving with like our bombs and the codes or something. I don't know. This is
Everything uses AI now, right? Like,
yeah.
nowadays there's like the next generation soldier platform that's being worked on, which is literally supposed to integrate like intelligence and communication stuff into the equipment. Like I remember, because I'm Czech, we love our firearms, we bring them everywhere. We're kind of like America with this, except we don't have mass shootings. So, kind of I feel like we have a win-win when it comes to this. But because of that, I do kind of follow what's going on to some extent there. And I remember seeing there being like scopes that were developed for the U.S. military, where they had like, basically a ballistics computer integrated into the scope, which means, very simplistic manner, every rifle has AI built in. So if they're doing that with like a rifle that a normal soldier is carrying, I guarantee you every little piece of technology will have already has AI. Like the F-35, the way it flies is like entirely computerized. The plane was designed to be unstable, and if the computer fails, it can't fly, because naturally, without all that computer controls and the AI that's running the plane, it just falls out of the sky.
So I think a lot of people, especially like people like me who have ingested a lot of sci-fi and stuff, and sorry for playing devil's advocate, but we're talking shit.
Yeah.
But so there's kind of two fears. My personal big one is the idea of sentience, and if something is sentient, that means it's feeling something. So if we're giving computers the ability to feel and sense things, like at what point does the unit have a soul, right? Like, to quote so many different like things. And then on the other hand, this is less one of my fears, but the fear of AI and computers taking over the world. Do you have any opinions or sort of comebacks for either of those sorts of scenarios?
Yeah, I think those two are quite fun questions. I don't think I really have a good answer to either. As far as like the sentience of a computer, I think it's hard to define how we would know that it is sentient, or if it's just very, very good at pretending to be. Because how will we as people tell the difference? And there's actually kind of a funny side note for anybody that doesn't follow AI as closely. But if you saw in the news how like Sam Altman got kicked out of OpenAI, then he got brought back, and this whole scandal that happened around that, there are a lot of people that are actually speculating that it had something to do with Ilya, which is one of the other like major people within OpenAI, seeing a development in AI that they've made that terrified him, based off of some comments that he made right around that time. So if you want to peddle in conspiracy theories, there's a lot to peddle around when it comes to sentience right now, being developed already. Now, to be clear, that is kind of a more kind of for the amusing side. I don't think we're there yet, or even that close to it. And the concept of an AI having a soul, I think that's partly kind of more of a theological question. So I'll leave that up to other people to discuss. As far as the concept of AI taking over the world, so there's something very interesting that I saw recently, where on Twitter I saw a tweet from a developer at OpenAI who put out a tweet where he was like talking about some work he's doing, and he mentioned that he's working on fixing the laziness issue with GPT. And I was like, oh, that's interesting. Like, what does he mean by the laziness issue? And I looked into it, and it's literally the laziness issue is the AI being like, oh, look it up and do it yourself instead of doing the work. Which I was kind of like, well, I doubt it means that with GPT-4, they're like, ooh, it's self-aware now. Wow, we should all be scared. But it was funny that like the model reached a point where it was like, oh, just do it yourself. I'm not doing this. Because it makes it feel kind of human, where it's like, oh, I'm not doing this, you do it, in that way. So, it's quite interesting. I think we're a lot closer to the stage of, some AI kind of in a way taking over the world the way it runs it. than I think most people believe. Like that's probably a far bigger risk than trying to figure out if AI has a soul.
So where do you see AI in like 3 years?
So I think we have a few major questions to answer when it comes to AI. We need to firstly figure out how to get it to understand the physical world, because right now, we can run stuff in a computer. It can interact with digital data and stuff, and maybe if we assume that it is actually an intelligent AI, which we'll get to at some point, I'm sure, it can I don't know, read Wikipedia and learn about stuff the same a person would. But that doesn't mean it would really get it, right? That's about the same kind of understanding that like a normal person, not a normal person, but like a human being would have about how something works on the quantum level, right? Like we can describe entanglement very precisely. We can have an understanding of how it works, what it acts on, how it can affect stuff in a very precise way. But also we kind of have no clue how it fucking works in the, like something just falling, right? We don't have that same intuitive understanding of how that operates. I think that is one of the major things we have to do, where people are working on building, I guess you could think of it as like a world engine for AIs to learn on and play in. I think that's one of the like a major development, so it understands how the world works. And then I think another major step is logic, because with these LLMs, they kind of understand some logical stuff, right? But to be fair, but they still make the same mistakes people do, which are like kind of an obvious logical failure. But when we quickly reply, we make that mistake. It's if you're drying 3 t-shirts on your balcony, how long, and it takes 3 hours, how long would it take to dry 9 t-shirts? Well, instinctively, a lot of people will immediately respond about 9 hours. But when you think about it, it's like, well, there's no time limit. So there's no like correlation between the amount of things you're drying and how fast they're dry. So they would all dry in 3 hours. So there's these problems with how it understands logic. So that is another major development, that somebody has to kind of build this. I'm just going to call everything an engine, like a logic engine for AI. And then I think from there, it's just a question of, I think, for some people, it might be the interaction side where they want to build robots, but I don't think interaction is that much of an issue, because we have surprisingly advanced technology for like interacting with the world within some limited means. So I think the real part will be the input, which is what we worked on with the computer vision stuff, where it's like, well, now it needs to be able to understand everything around it, in the sense of like perceive it, which is what we were trying to work on with like the computer vision on the whole electromagnetic spectrum and beyond. So I think the logic side and the world engine side is probably going to be solved in the next 3 years. It might not be trained off, like done training properly, but I think someone's going to build those systems to train it on. And as far as the computer vision, kind of the input sensory side, that I think based on what we find out is a bit further away.
Can you project in the next 30 years?
Oh, there'll just be no people. We're all robots.
Yeah, fair enough.
I'm being a little hyperbolic, but yeah, like that's so far out given the current rate of technology innovation around AI that like I have no clue. I'll be happy if I'm still alive and doing whatever I want to do. I think that's a good goal for 30 years away, given the current pace of innovation.
Yeah, I agree. What are the challenges that you face in the field, whether it's some of the technical, bureaucratic, or financial barriers?
So I think bureaucratic, the EU likes to get scared and ban a lot of stuff. But for anybody that has had a look at Biden's executive order, it was surprisingly tame. I think a lot of people expected a lot worse of an outcome on it, but also we're still in a period where we're waiting on the exact specific guidelines of how that's going to work out. But the US likes to be ahead on a lot of this stuff, so I don't think it's gonna be too bad, because if the US restricts it too much, China will just build it, and then it's bye bye America and bye bye Europe. But so I think bureaucratic isn't as much of a worry. The financial side is always going to be an issue with this, right? Because you're training massive models that are incredibly complex, that take an insane amount of compute. So you have to get that money from somewhere. But at the same time, like, people are throwing such absurd amounts of money at this that I think if you have the right idea and you're dedicated enough to it, you can find the money to train a model if you can figure out what it could be used for. So I think a great example of this is there's a company that is working on a model where they want to integrate it in certain ways that it's going to work. And before they even had their product done, so they haven't even, so they were like pre-product company, they raised money at more than $1 billion valuation. So they had no product, nothing anybody could use, but they already were worth more than $1 billion based on how many investments they got. So I think there's plenty of money floating around it as well. So the issues are, I think, primarily technical. In, can we do this stuff? Can we get the resources to the compute resources to do this stuff, and things like that? Because like one of the issues of what we're looking at with the computer vision stuff, and like why we were like, okay, well, this is just not feasible to do right now at a scale where it would make sense, was just the sheer size of like trying to train a model on something that complex. We don't have quite the technical capability yet. We thought when we were looking at it early on, and for a while, we were pretty convinced we could do a part of it, and then we can kind of continue from there. But we basically ended up asking, like, okay, this is not technically possible yet, unless we would be using literally the absolute cutting edge of what's out there, which there's already like 100 other people, in every major city that want to use that. So it's just not available to us at all. So I think it's all about the technical limitations, be it the hardware of, can you get enough computing? Can you have enough memory to train, to kind of hold the data and the model that you're trying to train? And then can you figure out the math? Because that's all this machine learning and stuff is, right? It's just math.
What are your favorite applications or uses for AI, whether it's something that you use personally or just conceptually?
So I think, so personally, I use AI a lot for like random things. I think I'm going to use a very narrow definition of AI, where I'm talking about kind of the more cutting edge stuff. Like, what would be an example? Like, like using stuff like the GPT models or like Midjourney and stuff like that. And this is going to be kind of an obscure application of it, but I have some friends where whenever I text with them, we would like use like GIFs and stuff like that, and I was always like, I can't find the right kind of GIF or picture or whatever to send. So I've actually started using Midjourney and the DALL-E 3 model to just tell it what I want as a response. And then I send that as like a sticker in iMessage. So in a very personal application, I think that's my favorite way to use it, because it's like, finally I can send the exact kind of thing I wanted. But in a and like a real professionals, like a proper more serious setting, GPT is like surprisingly useful when you're trying to like quickly research and learn about a specific area. Or like if I'm going through, a lot of stuff I was doing on the computer vision, I had to read a ton of research papers. It's really great. Like, you feed it a PDF of some research papers and you just ask it a bunch of questions, and then it always references like where it got it in that paper, so you can quickly check, like, oh, if you're like, that doesn't sound quite right, you can check it. Usually it's surprisingly often correct. You still have to make sure that you check it if it doesn't feel quite right, but it's more reliable than I think a lot of people would expect. And then as a conceptual thing that's not quite here yet, there's a thing that a guy that's called Avi Schiffman is working on. If that name sounds familiar to anyone, then you might know him from a website that he ran during COVID. So this wasn't really like an international news, but it broke all over the US, where he had like a COVID tracking website, like one of the first ones that was used by everyone all over the world. It was the one that had like the pretty map on it. So I think that's how most people remember it. So he was the guy behind that. And right now he's working on something that he's calling the tab, where it's essential. So this is going to sound a little creepy, but the applications of it seem really cool. And we're all being recorded already anyway. So I'm like, who cares? But it's essentially like a little thing that you wear around your neck. It has microphones on it and it records everything you talk about with everybody around you. And it's all done locally, so don't worry that it's going to get sent off somewhere. I think his version's the one that does it all locally. Yeah, pretty sure. I think his version is the one that transcribes everything locally, takes notes out of everything locally, and then stores it in your with your account. All the kind of useful notes out of every conversation you have all day, every day with everybody. And then you can just ask it stuff. You'd be like, hey, last night I was the guy I was talking to that mentioned he went to Harvard but dropped out after 6 months because of his mom. What was his phone number? And you're like, how do you find that out in any other case than if you have something that's recording you that like makes notes like this, right? And it lets you kind of reference normal real world conversations, but also the important bit of it to me is like it lets you reference them in like obscure little bits of information you remember. And I think for me, a big part of it is like I suck at remembering names. Like I have to like hear people's names like 5-10 times till I really start to remember it. So being able to seeing his like demos, because he's already got it out there with some early users, but it's still not done yet. So it'll probably be another 6 months to a year until like everyone can go out and buy one. But I saw his demos of where he was literally asking it like kind of in this format, like a guy I spoke to last night at the party who went to Harvard, who said this, what was this other part of conversation he mentioned. To me, that is like the dream of how to try to find random information I forgot, because anybody that knows me like at least decently well will know that half the people that I ask about, I'll kind of describe it in this kind of way, because I just cannot remember names. I don't know what's wrong with me, but I cannot remember names.
Me neither. My mind is like reeling with that one. It's like I'm in the same boat. I can't remember names. I just have mashed potato brain. Something goes in one ear, out the other. So I would find that incredibly useful, except I think there's like instances where like for me, I work in like social services, so I wouldn't be able to wear it to work because I deal with confidential information. So then I would have confidential information at home or wherever I'm at or whatever. And then also, I imagine the police, they could, if they have a search warrant, not that I'm like out there committing crimes, but just like, if you say somebody around you says something or whatever, it's on, like, it's sort of like on the record. But I think that's really interesting though. Or go ahead.
So, yeah, as far as like the police record, that side of it, because I think a lot of people in tech are like, oh no, I want my privacy, while also wanting stuff like this. So people are very conscious in the way that they built this, where it's like you don't want anybody else to access this. And people are a lot more security conscious than like Amazon with their Alexa type stuff, because like Amazon Alexa recordings, they save, like they keep those. So with this kind of stuff, it's like it records it, it transcribes it. As soon as the transcription is done, deletes the recording. As soon as it gets the note out of that transcription, it deletes the transcription. And then the stuff like the notes that it stores are stored locally, so you can just encrypt your memory. And then, okay, police has a warrant. Good luck trying to get into my encrypted memory. Like I would have to tell you how to access it, and I have no legal obligation to do so. So, like, there's good enough ways to be like safe enough. I think like that kind of. I don't think you could wear his current version if you're doing social work, but probably within, we'll get there soon enough where like the security on this, like, yes, you can wear it wherever. Because keep in mind, you do social work, your phone's around you, that records everything. Well, not everything, but like if you have like voice activation enabled, like Hey Siri or Alexa or whatever, that periodically records bits of sound that it sends off to like Amazon or somebody. Well, Apple doesn't send it off, Apple Store, whatever. Point is, like, that's recording and you can still do your work. So there's ways around this that are like safe enough.
And what was that called again? The tab?
So the tab, yeah. Just look up Avi Schiffman. I think it's a much easier way to come across it, because I think the tab is a name of about 300 different pubs in London alone. I think, from one of the things that we talked about is like the kind of fear of what's going to happen with AI. And I think I'm a lot more like casual about it than I think a lot of people would be. But I think a lot of people aren't considering kind of in a way the inevitability of it. Because if let's say like Europe, US, everybody bans it. There's nothing stopping somebody like at home just building their own shit, right? It's like you can. I think an example that is kind of comparable to this is, I think, Germany, right? Germany basically bans guns for normal people to have them. And for a while that was effective, but now there are like whole groups of people in Germany who just 3D print guns and have them because fuck you, you're going to take my guns away. And I think, for a lot of Americans, I'm assuming a lot of like, at least like for the audience that's American for this podcast, but even those that aren't, you might kind of understand the American stereotypical sentiment of like, yeah, like fuck you, you're going to take my guns. Like people are going to have that same attitude with everything. Like there's people that try building a nuclear reactor at home for fun, right? And then they can't get the radioactive material because, fortunately, like stuff like uranium's a bit harder to, get without anybody noticing. So, it's a very good thing. But when it comes to something that's computer code that I can train locally, like, yes, you might delay it a little bit, but firstly, there's always going to be some foreign government that's going to do this. Like if every country in the world agreed to ban it, I will guarantee you will have North Korea or Iran or somebody like that still being like, fuck you, we're doing it anyway, right? There's always going to be somebody. So it's better that everybody builds it. It's almost like the whole nuclear deterrent idea, because somebody's going to do this. And if we hide it away, it's way more likely we'll fuck everything up.
I think that's a great way to end it. Thank you so much. I really appreciate it.
Thanks for having me on. It was great fun.
Yeah. If anybody wants to check out do you have any like projects or anything out there, things that people can check out?
There's some stuff. I think simplest thing is just Google me, and then you'll come across my social media, and you can see what I'm doing at the time. I use Twitter a bunch, but then sometimes when I don't, I end up posting stuff on LinkedIn. So Google me, one of the two will pop up, and you can see what I'm up to at the time. Right now, because with the computer vision, we ended up being like running into a lot of issues, fast viability for now. So we ended up laying that off. So right now I'm actually working on a thing for journalism, which is an interesting jump. But if you want to have a look at that, it's called intio.news. We have a waiting list. We'll hopefully be launching. Oh, actually, by the time that this is out, we'll probably have like an early beta that's available, that's there. So if you're a journalist, you can check that out. But I think just generally, Google my name. I have a rare enough name that I pop up first 20 results or something. So look me up and you'll see. Thanks.
Sweet. Yeah, I'll throw some links up there so people don't have to Google unless they really want to. But Allison, thank you so much. I really appreciate it. I feel better. And also, I was going to say a little bit now more nervous about technology, but also not as nervous. It's weird.
It will
Change is
destroy us all,
scary.
but it's going to be okay.
Yeah, we're going to destroy ourselves. Let's be real. All right. Well, thanks so much.
Thanks. Have a great day, everyone.
That's a wrap for this month's episode of Talking Shit About. We'll be back the first Friday in February with a very special Valentine's Day sort of themed episode. If you want to support the show, you can give it a rating, share it with your friends, your family, your coworkers, some random guy on the street, whatever works. And we'll be back, like I said, next month. And thanks for listening.